Okay, welcome you all for today classes. In this today classes, we are going to start a new topic, that is the definition of the absolute gauge, atmospheric and vacuum pressures. Okay, so here, if you remember this figure, then you are able to define all these pressures. Okay, in this figure, if you are taken this atmospheric pressure as a reference pressure line, then the above the atmospheric pressure is called as a gauge pressure. Above the atmospheric pressure is called as a gauge pressure, that is if you are taken this atmospheric pressure as the reference line. Okay, and below this atmospheric pressure is called as a vacuum pressure. Below this atmospheric pressure is called as vacuum pressure. Suppose if you are taken this absolute zero pressure as a reference line, then above this it is absolute pressure above this absolute zero pressure is called as a absolute pressure. Okay, and this vacuum pressure is nothing but gauge pressure minus this absolute pressure, that is our vacuum pressure. Okay, so these will show the definitions or relationship between the pressures. Okay, so we'll see the definitions here. Two different systems two different system one is it is measured above the absolute zero or complete vacuum. It is called as the absolute pressure. This is the absolute pressure above the absolute zero pressure, that is one system. Second one is if the pressure is measured above the atmospheric pressure, and it is called as the gauge pressure. There are two different systems. One is if you are taken this atmospheric pressure as a reference line, or and if you are taken this absolute zero pressure as a reference line, then we can define these gauge pressure, vacuum pressure, and absolute pressure. Okay, so here those two systems are shown in here. Okay, the pressure below the atmospheric pressure is called as vacuum pressure. The pressure below the atmospheric pressure is called as a vacuum pressure. Here, the pressure below the atmospheric pressure is called as a vacuum pressure. This is what we defined here. The pressure below the atmospheric pressure is called as a vacuum pressure. Next, absolute pressure is equal to atmospheric pressure plus gauge pressure. So, this absolute pressure is equal to atmospheric pressure plus uh, plus gauge pressure. Up to this part, it is atmospheric pressure plus gauge pressure is called as a absolute pressure. Okay. So next, that is given by P absolute is equal to absolute pressure is equal to P atmospheric plus P gauge. Okay. So now vacuum pressure is defined as the atmospheric pressure minus absolute pressure. Vacuum pressure is defined as absolute pressure minus atmospheric pressure minus absolute pressure. Atmospheric pressure minus absolute pressure will give the vacuum pressure here. Okay, vacuum pressure is equal to atmospheric pressure minus absolute pressure. If you are taken this absolute zero pressure line is a reference line. Okay, next atmospheric pressure at sea level at 15 degrees Celsius is 101.3 kilonewton per meter square. Atmospheric pressure at the sea level at 15 degrees Celsius is 101.3 kilonewton per meter square. So we can measure that atmospheric pressure at the sea level, and that sea level is maintained at 15 degrees Celsius, then it becomes 101.3 kilonewton per meter square. The atmospheric pressure head is 760 mm of mercury, or we can say that 10.33 meter of water. The atmospheric pressure is measured in two ways, with respect to the mercury level and with respect to the water. So that for mercury 760 mm of mercury or 10.33 meter of water. Okay, so this is about the definition of this gauge pressure, atmospheric pressure, and vacuum pressure. So we can define it by two systems. By taking that atmospheric pressure as a reference line, we can define the gauge pressure and vacuum pressure. By taking the absolute zero pressure as a reference line, we can define the gauge pressure, vacuum pressure, and atmospheric pressure. Just we have to remember this figure, and also we can define these things. Now next move on to the next topic, that is measurement of pressure. How to measure that pressure? So already we defined that absolute gauge, atmospheric and vacuum pressure. So how to determine, how to measure this absolute gauge, atmospheric and vacuum pressures? What are the instrument we are using to measure this pressure? Okay, that we have to discuss. That is nothing but measurement of pressure. Okay. So first one is the manometer, the measurement of pressure by using the manometer devices. So what is that manometer? The device we use for measuring the pressure at a point in a fluid by balancing the column of fluid by same or another column of the fluid. So it is the one device which is used for measuring the pressure at a point in a fluid. So in this we are having some fluid. In that fluid we need to find out the pressure at a particular point. So how to find that pressure at a point in a fluid? By balancing the column of a fluid by same or another column by the column of the fluid. So that we have to see here next. So this is the manometer, here YouTube manometer. So these two are called as a column. If you want to find out the pressure at this point A, then you have to make the balancing of two columns. That's what the definition here. Column by balancing the column of the fluid by same or another column of the fluid. Okay. So again we are having different types of manometers here. Simple manometer and differential manometer. In the simple manometers, we are using piezometer, U-tube and single column manometer. So in the simple manometer, we are using the piezometer, U-tube and single column manometer. And the second one is the differential manometers. So these two are the types of manometers. Okay, manometer is a device which is used to measure the pressure at a point in a fluid by balancing the column of fluid by the same or another column of the fluid. By using this column, we can balancing the fluid. So by doing this, we can measure the pressure at a point in a fluid. Okay, there are two types of simple and differential manometers. In the simple manometer, piezometer, U-tube, and single column manometer. Okay, next one is mechanical gauges. So in the measurement of pressure, one device is manometer and next one is mechanical gauges. Okay, so these are the devices used for measuring the pressure by balancing the fluid column by the spring or dead weight. So these are the mechanical devices, or the gauges are the devices used for measuring the pressure by balancing the fluid column by spring or dead weight. So here we can balancing the column fluid by the same or another column of the fluid only. But here we can balancing the fluid column by the spring or dead weight. Spring or dead weight. Okay. So in again we are having different types of mechanical gauges: diaphragm pressure gauge, burden tube pressure gauge, dead weight pressure gauge, and bellow pressure gauge. Okay, these four are types of mechanical gauges. Okay, so what is the difference between the manometer and the mechanical gauges? In the manometer, the fluid is balanced by column of the fluid by the same or another column of the fluid. But in this mechanical gauges, the fluid is balanced by the using spring or dead weight. Okay, again these are the four types of mechanical gauges. So next one is the piezometer. Now we will discuss it one by one. So in simple manometer, piezometer, U-tube and single column manometer. So we will discuss it one by one here. Piezometer. Okay. So this figure will show, the figure number 2.8 will show the piezometer. Okay. So here it is having one pipe or what you call it. It is a pipe or some fluid. At this fluid we need to find out the pressure at the point A. Okay, and it is having only one column 2. Okay, so one point is connected to the point where the pressure is to be measured, so that this point, the pipe, or you can say that the column, one uh, point is connected to the point where the pressure is to be measured. So one side of the point column is connected to the point where the pressure is to be measured, and other end is open to the atmosphere. This end is open to the atmosphere. Okay, the rise of liquid gives the pressure head at that point. So whatever the rise of liquid in this column will gives us the pressure at head at that point, pressure at this point. Okay, then the pressure is going to be measured. P is equal to rho g into h. Rho is the density of this fluid, and g is the acceleration due to gravity, that is 9.81, and this is h. H is the height of this rise of fluid in the column. Okay, column pi. Okay. So pressure at that point P, A is calculated by using this formula, that is rho gh. Rho is the density of the fluid, g is the acceleration due to gravity, and h is the height of that rise of fluid in the column. Okay, the unit of this pressure is Newton per meter square. Newton per meter square. Okay, the piezometer is the device, and it is coming under the types of manometer. Okay, one end of the column is connected to the point where we need to find out the pressure, and one end is open to the atmosphere. Okay, so we need to find out the pressure at point A, then the equation is becomes rho g h. Rho g h, this we have to remember. Okay, next one is the U-tube manometer, so that it is used to find the gauge pressure. It is used to find the gauge pressure. Okay, uh, one point is connected to the point where the pressure is due to be measured. The one point of this U-tube is connected to the point where we need to find out the pressure, and other end is open to the atmosphere. This other end is open to the atmosphere. Okay, the pressure above the datum line in left column. Okay, so this is the left column limb, and this is the right column limb. So these two are called as the limbs. Okay, this is the left column limbs, and this is the right column limbs. Okay, so the pressure above the datum line is line in left column, so this we called it as a datum line. This is called as a datum line because at this point we are having the balancing fluid, means, so this much is balancing here, that's why you can take it as a datum line. Okay, so pressure above the datum line in left column, so this left column, that is P is equal to, so this pressure at point A, that is pressure at point A plus rho 1, because here we are having the h1, rho 1 g h1, rho 1 g h1. At this point, at this side, we are going to find out the pressure at point A by using this equation, that is P is equal to P plus, so already there is some pressure is there, that plus h1 into rho 1 into g. Okay, same pressure above the datum line in the right column, so this is the right column, pressure above the datum line, this is the datum line, we are having what, P is equal to rho 2 into G into H2. We don't have P here because we don't have any points to find out the pressure here. Okay, we are having one point here, that's why we can use this pressure P, but in the right column we don't have any point to find out the pressure, that's why we can take only rho 2 G and H2, rho 2 G and H2. So equating these two equations, here it is also P is equal to there, P is equal to there, that's why we have to equating these two equations, we will get, and simplification we will get that P is equal to rho 2 G H2, that is rho 2 G H2 minus of rho 1 into G into H1, rho 1 into G into H1. This is the equation in the U-tube manometer to find out the gauge pressure, Okay, one side pressure we have to take here, another column pressure we have to take, equating these two we will get the pressure at the point A, because this is the pressure at point A, this is the pressure at point A, that we have to find out by using this equations. Okay, rho 2 G H2 and rho 1 G H1. Okay, why it is rho 2 and rho 1, the density of this fluid is different, and the density of this whatever the fluid we are using is different, so these two fluids are different, that's why the density of those two fluids will different, and here it is the H1 and this is the H2, and G acceleration due to gravity is same for in both the sides, right? Or you can write P is equal to G into rho 2 H2 minus rho 1 H1, so that is also, this is about the U-tube manometer to find out the gauge pressure. Okay, next, the same U-tube manometer is used to find out the vacuum pressure. pressure. Okay, so in this where we can find out the gauge pressure, the atmospheric pressure is less than this fluid pressure. Atmospheric pressure is less than this fluid pressure. What happens, this fluid is rise in this column if the atmospheric pressure is less than this pressure. Okay, when the pressure is exerted in this pipe, then what happens, the fluid is pushed in and rise in this column because of this atmospheric pressure is less than this pressure. Okay, that's why it is called as a gauge pressure. If the atmospheric pressure is more than this fluid, then we have to find out by vacuum pressure, because this atmospheric pressure will pushes this column and it will goes down. The column liquid column will go down. Okay, so here also one point is connected to the point where the pressure is to be measured. This point is connected to the this end of the column is connected to the point B, where the pressure is need to be find out. This is one pipe. You can take one point pipe. So in that we are having the fluid. So that is connected to the one column, one end of the column, where the pressure is need to be find out, and the other end is open to the atmosphere. The other end is open to the atmosphere. Okay, the other end is open to the atmosphere here. The pressure above the datum line is in left column. See here, this is the datum line, that A is the datum line. The pressure above the left column, this one is, okay, that is given by P. Already here we are having that one pressure P plus rho 1 G H1. Here this much only the pressure rho 1 G H1 plus rho 2 G H1, because this fluid is again different and this fluid is again different. This is rho 1 GH1 and this is the rho 1 GH2, rho 2 GH2. So that is given by here. The pressure above the determinant right column, there is no pressure at all. There is no fluid at all at that right column above the determinant. Then you have to take that P is equal to 0. P is equal to 0. Then again equating these two equations. Again equating these two equations, you will get that P is equal to minus of rho 2 GH2 plus rho 1 GH1. Just P is equal to what? You have to take it this side, minus of rho GH1 minus plus of rho 2 GH2. This is what the vacuum pressure is always gives us the negative pressure. That is what here sign indicates. This negative sign indicates it is a vacuum pressure. Vacuum pressure. Okay, it is also always in negative. Okay, so next vertical single column manometer. Again there are types of manometers are there. Vertical single column manometer. Okay, so here this figure number 2.15 shows the vertical single column manometer. Vertical single column manometer. Okay, so here XX datum line in a reservoir and right limb when it is not connected to the pipe. So this whatever this excess datum line is there, the fluid is at this position when this pipe is not connected, when this column is not connected to the pipe. This is the pipe. We need to find out the pressure at point A. When it is not connected to this column is not connected to the point this pipe, then this whatever the determinant is there here XX, so this fluid is up to the point here XX. Okay, when connected to the pipe, the heavy liquid in the reservoir pushes down. So here it is, if you are taken, this is a heavy liquid, it will, when it is connected, this end is connected to the point A, this fluid is pushes down here, then YY is becomes the new datum line. YY is becomes the new datum line when it pushes the heavy fluid pushes this light. Okay. Uh, so S2 rise of heavy fluid in right limb. This is the S2 rise of heavy fluid in right limb. H1 is the height of center of point above XX. So H1 is the height of center of point above XX. Here, this is the XX and this is the height above the height. And PA is the pressure at point A. This PA is the pressure at point A. Area A is equal to capital A is equal to cross sectional area of the reservoir. Cross sectional area of the reservoir. Small a is equal to capital A is the cross sectional area of the reservoir. This reservoir area. Small a is equal to cross sectional area of the right limb. Small a is equal to cross sectional area of the right limb. This is the right limb. Okay. and S1 is the specific gravity of the liquid in pipe. S1 is specific gravity of liquid in pipe. Okay, so this is the pipe. This fluid specific gravity is given by S1. S2 is the specific gravity of heavy liquid in the reservoir and light right plane. S2 is the specific gravity of the liquid in the heavy liquid in the reservoir and right limb. Okay, and rho 1 and rho 2 are the density of liquid in pipe and reservoir. Delta H is the fall of heavy liquid in the reservoir. This is the X and Y determined. That is the fall of heavy liquid in the reservoir. That is given by delta H. So these are some notations we use in vertical single column manometer. Okay. Next, let it continue. Okay. Fall of heavy liquid in the reservoir is equal to rise of liquid in the right limb. Okay. Whatever the fall of heavy liquid fall in the reservoir, which is equal to the rise of liquid in the right limb. So how much amount of liquid is filled in this reservoir, that is x to the y, so that much amount of height is raised here. Okay, that's why it is given by heavy liquid A into delta H. So the capital A is the area cross sectional area of the reservoir and delta H is the fall of liquid in the reservoir, that is equal to small a into H2. That is small a is the area cross sectional area of the right limb pipe. So that is given by A delta H is equal to A into H2. So that delta H is equal to A into H2 by capital A. Okay. The pressure above the YY in the right limb. The pressure above the YY in the right limb is given by rho 2 G2. So this is the rho 2 and G2 into, so delta H plus H2. Delta H plus H2. So this is the delta H plus H2. This is what the pressure above the YY line. This is the YY line. So this is the delta H plus H2 into rho 2 G2. Okay. Pressure above the YY in the left limb. So pressure above the YY in the left limb is equal to rho 1 G into delta H plus H2. Delta H plus H2, this much. From this to the height, this one, that is delta H plus H2 plus PA, because we are having the pressure at point A. Okay. So equating these two and make the simplification, we will get that PA is equal to rho 2 G delta H plus H2 minus rho 1 G delta H plus H1. So is equal to delta H is common here, just take it outside, and rho 2 G rho 1 G plus H2 rho 2 G minus H1 rho 1 G. So this is the pressure in the vertical single column manometer. This equation is used to find out the pressure by using vertical single column manometer. Okay, so just we have to go through this in detail, so we'll get that answer. Okay, and next one is A delta H is equal to AH2, delta H is equal to AH2 by A. So that you can equating or you can substitute that equations. You will get A H2 area into rho 2 G rho 1 H1 here, delta H is there, that we have to substitute by using these equations. We will get that answer here. If the ratio of A by A, this A by A is small, can be neglected. If the ratio of A by A is the small and can be neglected, then it becomes H2 rho 2 G minus H1 rho G1 rho 1 G. Okay. So this is the equations to find out the pressure at point A by using the vertical single column manometer. Vertical single column manometer. Okay. Next one is the same inclined single column manometer. Inclined single column manometer. Okay. So here it is in vertical position. If it is in vertical position, then you can use this equation. PA is equal to H2 rho 2 G. So this H2 rho 2 G minus H1 rho 1 G. Okay. If it is in inclined position, this column is in inclined position, then the equation is becomes pressure at A is PA rho 2 H2 rho 2 G minus rho H1 rho 1 G. Okay. Substituting the value of H2. So whatever this value is there, you have to substitute it. That is PA is equal to H2 is nothing but what here, L into sin theta. Why it is sin theta? It is inclined with some angle, inclined with angle, that is the sin theta. So just instead of h2 we can write as L sin theta rho 2 g minus rho 1 g1 h1 g, rho 2 g minus rho h1 rho 1 g. So if it is inclined, then we have to substitute the value of h2, that is L sin theta. Will get the pressure at point A by using this inclined single column manometer. Inclined single column manometer. Okay. So with this we will complete today video. In the next class we will discuss the differential manometer. Again there are two types of differential manometer that we have to discuss it in next class. Okay. Thank you.